Hi, everybody. Thanks for joining this session, and thanks to the program committee for accepting my submission to talk about this. What I'm going to be talking about is something I've been playing around with a few people from kind of all over the internet on a project on GitHub, started by Chandra Sekhar Kode from India, a project called Sri, and I'll show you where to find that project. And just playing around with it and trying to figure out how to take Scala.js-based code bases and get them to be multiple platform and multiple clients from the single code base. This is only the second time in my life that I've given a live coding talk. So hopefully, just everybody keep your fingers crossed. Hopefully everything works out okay. But we'll keep it interactive. I have kind of a little bit of an agenda, and then the rest we'll go with wherever you guys want to go with this, and we'll experiment, okay? So a few key things. First of all, what is serverless? I don't want to necessarily go into what Scala.js is. I think everybody here is already familiar with it. And then the next concept is, what do I mean by one code base, and why is that important? Is it interesting? Is it not interesting? And so on. So let's start with serverless. What we've been playing around with is a concept where as much as possible of the functionality of a rich client sits in the client, the relevant functionality, of course. And the functionality of our server code is embedded in very, very simple functions that just permute or operate some very, very simple functional code against data that's stored in a database, to try to make the rest of the pipeline as functional as possible. Okay, so the particular flavor of serverless that I'm going to be talking about adapts this database interface language called GraphQL. So I'll explain what that is using this plot. This is courtesy of Prisma, which is a company that is developing this open source GraphQL interface called Prisma. So here's the sketch of this, right? So you've got the client on the bottom left. The client is, in this case, we're assuming a rich client. Could be an app, could be a could be a native app, or could be a web app, could be a React Native app, and so on. And then there's a well-defined interface where the data that this app is getting is not over what we are typically used to with a RESTful API, but rather GraphQL, and I'll show you how that works in a second. And then all of the server-side stuff, which is everything but the client in this diagram, is handled by simple functions on top of data that is stored all the way to the top right in the DB itself. Okay. So the core technologies we're going to be experimenting with in our live session here is Scala.js, React Native, Sri, which is the Scala bindings and facade for React Native, and GraphQL on the client side, and then on the server side is Prisma, which is a wrapper on top of Sangria, which is written in Scala, and then GraphQL as well. Okay, so what's going to happen is that the client is going to issue queries in GraphQL, right? Very, very structured, typed queries in GraphQL, which are going to hit this GraphQL server. Now, that GraphQL server, in my particular example, happens to be implemented in JavaScript, with at least the facades written in JavaScript with Sangria, which is a very, very cool, very flexible Scala-based GraphQL server. Now, that GraphQL server, in turn, is going to convert that query and pass it to other layers that are going to translate that into DB. So ultimately, what's sent to the database is what you'd be used to sending from your own application, in the way that I've implemented all the apps that I've written in the past, right? So you have a RESTful interface, and the server code translates that into some kind of query to a SQL database, a key value store, or a big data store of some other type. Okay, but in this case, we're trying to do things a little bit differently. And one of the reasons for introducing this GraphQL layer in the middle is that the GraphQL language is typed, right? So every field that you get, every data structure that you're getting is typed. Now, it's not Scala, mind you, So sometimes the types don't always match, but people around the community have done a really good job of coming up with translators and interfaces so that most of that can be hidden. The other reason for introducing GraphQL in the middle is that it allows for very clean and very simple ways of accessing data, only the data that you need. So one classic problem I had at my previous startup is that we had this really, really rich RESTful API. And every time a UI developer or a customer would say, hey, I need this other thing that I know you're calculating in your database, but it's not in your API, we would go and add something to one of our existing RESTful endpoints, right? The problem is that if you use an existing RESTful endpoint, that endpoint just ends up getting bigger and bigger and bigger and bigger, and people who didn't actually need that extra data are still getting it. They don't have a choice to just subtract out and ask for just what they need. On the other hand, if you try to create a new endpoint for every different use case, you end up with thousands of them, right? And that doesn't make any sense either. So, it's not a very flexible way of accessing data and just the data that you need, and you end up overfetching or underfetching, and then you have to add more endpoints. So that's the two main reasons where, for me, to investigate GraphQL, and we're standardized on that in my new company. Okay, so now let's see if we can do some live coding. Now, there's this morning I was trying to get all this to work, but there was network hiccups, so I tried to do this locally as well. So we will try the remote way, connecting to an actual cloud-based endpoint, so we can do serverless from here to the cloud. My guess is it's not going to work, so we'll default back to doing things locally. Okay, so we're going to keep this interactive. I don't have a specified time at the end, so if you have comments and questions, please mention them, and we'll take them as we go here. Okay, so let's go in, and so remember I told you Prisma is this nice wrapper CLI and a server-side component to make working with GraphQL endpoints nice and easy. So we're going to say, well, Prisma, please init a new project, and we'll call it Scala Days, and let's see if the network is cooperating. Oh, it is cooperating. Okay, so we're going to say, okay, what we want you to do is to, so we could set up a local database, and then that's what I do normally for development. But in this case, just to see how this works across the internet, we're going to use a demo server. In this case, and I've already logged in, so it's not going to ask me to do that. And I'll pick the US1 demo cloud server that Prisma has provided for dev testing. And we go, name for the service is Scala Days, name for your stage is dev. Okay, great. So what just happened is that we ended up with a brand new folder with a couple of files in it. So let's go ahead and look at those files. So the first part that we're doing here is really setting up our GraphQL interface that we're then going to write our client against. Okay, so what we're going to do here is that, so two files got created, right? First is a datamol.graphql, and so this is the actual GraphQL language. There's also this YAML file for how to set things up. We won't really need that too much right now, so we'll ignore it. Okay. So let's look at this file. So first you notice there's type, right? So that makes us all happy. There's a type called user, and you can refer to this type from other types and inputs and so on. You'll also notice that by default, an ID, which is globally unique, was created and a name was created. So this is fine, but actually let's go ahead and deploy this. So Prisma deploy, please have your fingers crossed the internet connection here cooperates. If it does, okay, great. So what just happened is that our CLI connected to the server-side code to go ahead and create this new type called user and its fields, right? There's a couple of these fields that are kind of automatically created for you on your behalf, for auditing, okay? So what we did is we created ID and name in that type user, all right. So let's come in here and say, okay, well, obviously it's not enough to have a user with just a name. We need an email. So we're going to create an email field here, save, and then we're going to run deploy again. So if everything goes well, there would be a database evolution in the back that has happened where this email field has now been created. Okay. So let's go ahead and connect to this endpoint using our browser here. Okay, so that we can enter. And so a lot of times when you're working with GraphQL, you'll notice that people will be using this playground, right? It helps you get your queries right. And again, you don't have to really learn SQL and all. It's very, very simple language. So we're going to say, well, please query all users for me. And for each user, please return the ID, name, and email. Okay. So, okay, of course, there's no users right now. We have a database that's live and up and running. We can query it, but right now there's no data actually in it. Now, while I'm doing that, I'm going to refer several times to this tab on the right-hand side for the playground, which is actually the schema. And this is really nice because because it's nicely typed, the language, this tool auto-generates the schema, and you can use it and figure out what's going wrong in your query, etc. very easily. Okay, so now we have a query that is basically vacuous. So now we're going to do a mutation. Mutation is the keyword in GraphQL to actually have an effect on the system. And so let's say we say create user. And so part of the process of Prisma making life easy for us is that it created a whole bunch of functions and a whole bunch of basically endpoints on a RESTful way of thinking on our behalf. So one of those is create user. We'll look at a few more as we go. So for create user, we're going to say, okay, well, the user that we want to create is actually has a name, which is Irfan. That's me, guys. And then we have an email that is going to be irfan@cashphysics.com. Okay, so now what we see here is there's still an error here. So let's see. Field create user of type user must have a selection of subfields. Okay, so that's telling us, hey, anytime you do a query or a subscription to a query or a mutation, you always have to return something, and that's a really good pattern anyway, but you're forced to do so. And the reason is that when there's a mutation, when the data comes back, you want to update the cache. So you need some unique way of identifying the entry that needs to be updated, and so you're forced to have some response. So in this case, we'll just do all of the fields just to see what happens. Okay, so now there is now a new record in the DB. We have a name and an email. So let's go ahead and rerun our query. And so there we go. That's there. So it looks like I ran it twice, which is awful because now my database actually has 2 users with the same name. This is not nice. So next thing we're going to do is we're going to go ahead and delete user, and we're going to say where ID is, let's just do the second one. Okay, so this is I'm just kind of interactively going through this. And of course, there's still an error because, well, we have to return a subselection of fields. We'll return ID again just to make sure that the right record got deleted. Okay, now we run the query again, and now we're back to 1. Okay, so this is good. But our user could make this mistake, or the rest of our code base could make this mistake. So let's fix this once and for all. There is a directive here in the system where we can specify unique. So we're going to save this. We're going to deploy again, and hopefully if everything goes well, the field email has now become unique. Okay, so the wrappers have kind of pushed that in as a database constraint. So now we come back in here, we create user again, and we get an error. A unique constraint will be violated on the user. Okay, so far so good. So what we're getting here is a sense of the flavor of this language, GraphQL. So let's say now we want to build a real application. We're going to create a post, and well, need a unique ID. So let's just get that out of the way. I guess a blog post or something should have a title. So you guys think string is okay for a title? Should we make it required? Yes? Okay, so let's make it required. Okay, no point of a blog post without a title. But interestingly, now we have an opportunity. So how about probably should have an author, right? So now what are we going to use as the author's record?
Is Prisma a vendor?
Prisma is a vendor, but it's a completely open source project. All the source code is available. And that's what I'm using. So Usually I develop using completely open source, non-hosted on my laptop, but in this case I just wanted to show that going all the way across, the way a serverless would work against something running in Amazon would work as well. But yeah, definitely check out a very cool project. And in the back it's actually using Sangria, which is a super, super awesome GraphQL server library. Okay, author. So what should the type of author be? User. I'm assuming just one user, right? And should we make that required? Okay, so you're getting the hang of this bang here, which is the field cannot be null. That's what the bang means. Required field cannot be null. Okay, so so what else do we need in a blog post? Anything? Content, text. Okay, text. Body. Okay. What should the type of that be? String. Should we make that required? Sure. Okay. All right. Why not? Okay. Try to be interactive here. Okay. So now we're going to save that. And we're going to do the same dance again. We're going to deploy it, which again looks at the current schema that's deployed versus the one that I've just pushed in. We'll compare them, and then we'll do the database evolutions to go ahead and make this work. While I'm doing this, really quickly, I want to mention, if you've done RESTful a lot, one other thing you need to deal with is versioning, API versioning. It's a total pain. I mean, it's just like, oh, I hate this stuff. Why can't there be just a simple way of doing it? And I've never come up with a really clean way of doing it. And you can read thousands of blog posts of good practices, right? But here, for example, if we added another field and we said, whatever, and string, if we don't make it required, anyone who doesn't even know the string exists continues to work against this API. Really, really, really nice, right? And then eventually, assume maybe you want this to be a required field in the future. Once all the users have upgraded and you can downgrade, you can then go in and add new functionality and add the bang at the end later if you wanted to, right? But this is really, really nice. You don't have to have /v1 and then /v2 in your URLs and your RESTful endpoints. So this is super useful. Okay, so we did push that, and all the fields did get created for this post type. So let's go ahead and now come to our playground and refresh this, and if all goes well, we will now have a schema that actually has post-related queries and types and so on, okay? So now obviously we can come in here, call a create post, and we see that to do a create post, we need to provide a structured struct, this type called post create input, which has a required title with a bang, a required text, and an author. And the type of author is either you're going to create a new author or connect an existing one. In this case, we already have one, so let's assume we do a connect. And when we do a connect of this new blog post to an existing user, right, we will provide either the ID of that user or the email of that user. Okay. You see how the whole thing, not with a lot of code, we were able to accomplish quite a bit, at least in my opinion, right? And then types were maintained, self-documenting, so that's really nice. Okay, so now we have a new type called post. So let's go ahead and do a query on all of our posts. So here, for example, there's other fields here. So we could say, hey, give me the first 100. I don't want all of them. But of course, we don't even have a single one yet. So in this case, we're going to say ID. What are the other fields? Author, title, text. Okay. Oh, of course, author is a nested field, so you have to select the subfields there. And so we're going to say, hey, just name and email. Okay. So that's great. Of course, we don't have a post. So all of that was pointless, at least for now, because now we're going to come in here. We're going to say, hey, please create a mutation. What I want to do is I want to create a post. And as you recall, as we went through it, the post itself is going to have some fields. So the post is going to have a title. Anybody propose a title? Come on, make it easy for me. What is it? Scala Days Wednesday. Brilliant, thank you. Okay, text.
Prisma seems pretty cool.
Prisma seems pretty cool. Bang is inside the quotation marks there. And then we say author. Okay, this time, remember, when we looked at this earlier, this was nested. So for the author, we're going to connect to an existing author. And in that case, we're just going to specify. Now, there's two fields that we could specify, ID and email. The reason why email shows up here is because email is globally unique. right? That's the only reason it's showing up here. Otherwise, it wouldn't show up here. It would just be ID, which I did to make my life easy here because I don't want to remember IDs. Although my email address is way too long, I need to find a shorter domain name for my new company. If there's any consultants out there for branding and naming, please reach out afterwards. Okay, no, I'm serious. Okay, so now of course there's still an error because I have not selected the subfields that I need. So what we're going to do is we're going to say, hey, remember we're creating a post here. So what was the title of the post? I just want to confirm it worked correctly, and then the author and the author's, let's say, email. Okay. So now what happens is, okay, create post was successful. Here's the ID that was generated by the system. Here's the title. And of course, the other fields went in. I just pulled out these fields only.
You have to return something if you're doing a create?
You have to return something. And again, that has to do with the fact that on the client side, you're probably doing some kind of caching. And so if it's a delete, you want to invalidate that after the return, successful return of the deletion. You want to invalidate, so you need something unique to return. If it's just a refresh of a page, you want to just populate and do a diff against the cache that's already there. So it forces you, at least Prisma forces you to return something. I actually don't know if that's part of the GraphQL spec or not. I haven't gotten that deep. We can look into it after. Okay, so we've got a post now. So now we go back to our query, which did nothing before, and all of a sudden now we have this structured, nice query. And remember, right, just your user being able to just come in and say, look, I don't need text anymore in their code, and getting less data is really, really, really awesome. Okay, so now we have some data. So now we're going to switch over to the world of Scala. So what we're going to do is open up a project that I've been working on that I will publish. Well, parts of this published in various places already. In this particular version, I will post. And I will post to Twitter about this as well, so if anybody wants to track it, they can take a look. So this project I'm calling a triple play because, well, I guess should be obvious, right? There's like 3 things in the, I'm used to peanuts with 2 peanuts in it, or peanut shells with 2 peanuts. Well, in this case, we have 3. So what are the 3? So it's iOS, Android, and web app all in one. And so the very, very simple project, right? And so just to take a quick look at it, right? So this is using React Native. So this is facades on top of React, which is a JavaScript project. So we're going to be coding in Scala.js with a bunch of interfaces for existing React Native components, systems, GraphQL handlers, and so on, right? So we've tried to abstract all that away. So we live in Scala as much as possible, but there's hundreds of thousands of people writing really cool JavaScript libraries. We still want to use them. And just like in the JVM world, Scala is able to interact with other Java projects and libraries. We're trying to do as much of that as possible here as well by creating these interfaces and facades. So this is one of the places where you set up your interfaces. So this is JavaScript libraries that are being used behind the scenes. This is built in the project. You won't have to worry about it if you want to dip your toes in it. So index.html. So the web part of this app will load using this very simple HTML, and this div ID is where our application will get injected. Similarly, if you're going to load an iOS app out of this, which we will try to do, fingers crossed, that will actually load from this interface. So all of this stuff is set up in a Giterate template. So that's very easy for you guys to get started. And then the actual code base here has got a few components. So Relay is the interface for GraphQL, which we'll see in a second. There's the web-specific interface, and then there is another one somewhere here for mobile. So mobile-specific components here. So we'll see this more in a second. So here's the entry point. So in the entry point, other than our imports, it's very simple. We're saying, okay, we're going to define main, and this is what Scala.js will look for to instantiate the app and inject it into the right location inside the DOM in the case of web, or in the app itself, right? Here, we're just doing a Sri. Again, Sri is the platform that we're using to hide all of the JavaScript stuff for React Native, okay? Which is how we do multi-platform apps using a single code base. So if you're web, right, do this, otherwise do this, and pretty much everything else in the code is going to be the same, but just the entry point is a little bit different. Okay. All right, so now let's get into it, and let's go to, well, if we're going to be rendering this thing called web.root, let's go look at it. So we registered some screens, and there's an error here, but I won't bother fixing it now. And then, so there's a web router that's set up here. And then what we'll see here is some script to get us started. So this is get or update schema, and we're going to run this first because this is the thing that is going to get the GraphQL spec, the schema, and translate it into Scala, so that when we're writing code, we don't have to actually worry about all the translations already done. We actually get a model that we can get completion on and so on. Okay, so to do that, all I need to do is to go back here, and I kind of lied to you that we don't need this, but we do. So here's where we're going to just export this endpoint and call, okay. So that just went across the internet to our endpoint, pulled out the GraphQL schema, converted it using all of this is open source, right? That a bunch of us are maintaining, converted it into Scala, and so this is where it's converted into. So let's go to models here, GraphQL models. So this here is completely auto-generated bindings for Scala for that particular GraphQL schema. So you'll notice this will start to get familiar a little bit. You remember create user, we called that earlier. You'll see that it's actually a native binding interface, so we don't really care. We're just going to call it, and the system will take care of the rest. And then there's a whole bunch of other things here where, for example, the return of post-create input, it has a certain type, and then that's how you can parse the output and so on. Okay. Okay, so suffice it to say, there's a very huge file that gets created with all of the various bindings and types that is now in Scala. Okay, so well, let's see. We're going to get a bunch of type errors because I'm sure that I did not retype this completely accurately, the schema that we generated. Oh, did we not get an error? How is that possible? Okay.
Scala.js, what part of this is Scala.js?
Everything, so I'm kind of, so Visual Studio Code is, when I go to Visual Studio Code, visually you think that's not Scala.js. Whenever I'm in IntelliJ, it's all Scala.js. Right?
Basically just Scala.
This is Scala. This is Scala.
Libraries that
That's right. That's right. So right at the top you see import Scala js.js, and then for example, at any point in time, the fact that the facades are taking care of a whole bunch of the messiness for you. Okay. And then if you guys ever want to, like if anybody becomes interested at the end of this talk to contribute, reach out on our Gitter channel. We can get you guys started. There's a bunch of cool things that we're doing that we need help on.
How different is this from the AWS Lambda?
Okay, so AWS Lambda is a way to take JavaScript functions and install them somewhere where if you hit an API endpoint that function will run. You can take any Scala.js function, convert it into a JS because that's what it transpiles into, and then install it into Lambda. So we're not doing Lambda style serverless here. We're trying to do this very data and functional oriented things where you can do the same thing that Lambda does using this code base. I'm just not demonstrating that today. Does that answer your question?
Yeah.
Okay. So I'm supposed to repeat questions, which I don't think I've been doing a good job of, but hopefully there's enough context in the answer for folks on the video to make it out, but I'll try to be better at that. Okay, so now we're going to go and actually look at what's happening. So the first thing I'm doing here is I'm drawing an app frame, and in that app frame there's a view, and the view is kind of like a div, but it's universal component, so it renders both in web as well as in our native apps. Okay, so this view has this navigation at the top, and then whatever else comes with the nav. So let's go look at the nav. Let's navigate there. Okay, and so this nav here is just drawing some static menu items. Okay, I won't go through all the details of that. So that's what's getting painted on this screen here. So this is a live view of, actually, let me refresh that. Oh, did not run the server. Let's run the server. Start web. Okay, so hopefully that runs. Sorry, say it again?
What kind of a web server is that?
This is just Webpack. launching a local server. Because I'm running in dev mode, it's doing that for me. If I was not running in dev mode, I would just run it as python-m, HTTP, whatever, just a command line. It's going to mount that just as, as long as the client looks for /index.html, it doesn't matter, because that's the only thing we need. Yeah, okay. Okay, so that actually reloaded. So let's just make sure that this is live. I know this is important to prove that it might be live here. And I'm not just faking it. So let's go in here and say, hey, where do we create the text? So let's just call it 2. And then we come back here. I'm running a lot of apps. So you see it's taking a few seconds. And of course, that's the Scala compiler. Mostly that was a Scala compiler, just taking its time a little bit and warming up. Okay, so you see home 2. So we know that this app is live and it reloaded automatically and took 2 or 3 seconds. So it's not terrible. But hopefully, as the compiler gets faster, the Scala.js transpiler will get faster, and then that gets resolved.
You're saying that if you run it once, it has to recompile, but if you run it a second time, it doesn't?
What I'm saying is that once SBT is nice and warmed, it'll be a little faster, and it should be warm now, so that went really fast that time. So let's try that again. So let's say do this, and as soon as I switch out, it's going to save the file and run it. So 1, 2, 3, 4, 4.5 seconds. That time. Okay. And this is a kind of an old laptop, so your mileage may vary, and I'm also running a whole bunch of apps here, so there might be a little bit of memory pressure. I haven't checked the GC pressure on SBT there to see why it's taking so long. Okay, so now we have a web server running, just running Webpack, right? The docs will explain how to do that. It's just yarn start web, and all this magic happens behind the scenes. And we see that there is this dashboard that is running. So okay, so now let's go and run tab 1x. Okay, so here's our post, guys. Come on, this is cool, right? Okay. Okay, so obviously that's not good enough. We want to get better. So let's go back to our playground. Let's create a new user. Let's say call him Martin. Let's say Odersky. He won't like that, but let's see. At least this way he'll watch the video, right? Okay, so we're going to create this user, and let's see if it works. Okay, that worked. And then we're going to come and create a post, and this time, well, create post, and this time we're going to make it Odersky and Excel.com, and then, okay, be creative, guys. What's the title for his post, his blog post?
Scala is over.
Okay, I'll at least put question marks in front of that. And the text for that, is it really? Is that okay? Okay. All right. So here we have it. We have a new blog post. We're going to connect it to Odersky's email, and boom. Okay. So now let's go back in and let us see what happened here. Okay, so what we're going to do is just refresh this page, and we have that listing. So now the listing is not very pretty, obviously. Now this is where the user interface designer would come in, and of course I'm not one, but we can clean up tiny little bits of it. We can, for example, go to post.js. Oops, not that one. We can go to post list. We can say, okay, instead of drawing this as just text back to back, can you, instead of that, maybe, let's just start out simple, say author name is going to go here. Okay.
Link tag or something in there?
Yeah, that's a little bit more advanced because I'm doing it both for web and for mobile. So you can't just do a link tag. You have to use a navigator. And the navigator is a little bit different. So, I mean, we can do it. It's not going to fit in this short demo time frame here. So we're going to say, okay. I'm going to say he wrote this title, and then we're going to, now, of course, again, with a real UI designer here, e dot title plus e dot text. Okay, and we'll insert maybe a, again, please pardon the lack of creativity in terms of UI design. So that should refresh quickly, just to fit the post in there. And so, we made a mistake here. So let's see. Oh, I know what it is. In our query, we didn't ask for text, and here I am, in a silly way, trying to print out the text. That doesn't work. So what happened there is all the queries that query got recompiled, and now we're seeing the post here. So now, a really nice thing out of this, another nice thing out of this is that suppose I say, look, actually we made a mistake. That wasn't a Dursky, because of course, why would a Dursky even write a post like Scala is over? That doesn't make any sense. So what we're gonna do is we're gonna come in here. Now, what you're gonna do is you're gonna watch this screen here, guys, okay? Don't watch what I'm typing. We'll catch up on that later. If this works, we're gonna say update post, and what we're gonna say is update post, excuse me. So let's shrink this a little bit. Okay, so update post where ID is, and then we have our post's ID, I hope. Yeah, no, that wasn't the one. This one. So we're gonna say, well, we're gonna update the post with that ID, and let's see. And the data for that is going to be author, connect, email, and I'll take the blame. Even though it wasn't me, it was one of you guys. Okay. Okay, I'll take the blame. So we're gonna connect it up. So hopefully that query runs. And then, oops, what did I do? Is there any red here? Of course. Surprise, I made this mistake again. Okay, so we're gonna get an ID back, and then a author back, and make sure that that author is me. So that ran, automatically updated. Okay, so now this is end to end, right? So how did that happen? Okay, this is really, really, really cool. So in GraphQL, remember, if you recall, I mentioned there's 3 types of things you can do with the schema. You can do queries, you can do mutations, and you can do subscriptions. So queries, we've done a bunch of them. Mutations, we've done a bunch of them. We haven't done a subscription yet. So the way that a subscription would work is that it's just as simple as anything. So you come in here and you say subscription, and I want to do it on a post, and I want to actually, let's say I want to do it on all posts, and I want you to return the updated fields, and also say mutation type, okay, and then yeah, so let's run that. See, now that's running actually, and it's waiting, it's blocked and waiting. Now we come back here and we switch this post back to odersky@com, and when we come here, you will see that there's, well, actually updated fields. I don't know why that didn't work. It should have listed the updated fields. Let me debug that for a second. You can also get previous values, which is really awesome because, again, to invalidate caches and so on, that can be quite useful. So let's do this again. We're going to update this, and let's see what happens. Okay. So, so yeah, we got a second update to this. Sorry?
You can stop and restart the...
Oh, that doesn't matter actually. The subscription is still live, which is really nice because and it can auto refresh as well. You can set up a subscriber to auto refresh as well. So I think the issue was that because I changed the connection of a nested type. So that's why the updated fields, because it wasn't a field of the subscription, it was a field of something else. It triggered, so you can go and refetch, but it didn't end up getting listed. So, if we had more time, we'd actually go and write the subscription in a way where we should be able to get the nested value as well. Okay, sorry?
Why would you use the subscription?
Why would you use a subscription? Okay. So instead of having a rich application that has a tremendous amount of data that is carefully selected through the entire schema of the server, refresh for updated data, it just gets the data that it wants, only just sips exactly the data that it wants using GraphQL, and then writes a subscription for the fields that it wants to refresh automatically. A WebSocket connection is created, and then the server will ping back and say, hey, I have this little piece of data. You don't have to re-get everything. Just this little piece of data that has been updated, and that comes back up, refreshes the cache of the client, and gets redrawn. Okay, and it's again very functional, functional, reactive, all the way inside the client, between the client and the server, and inside the server as well. Okay. So so that's so far so good. So we've talked about GraphQL at a very high level, hopefully enough to motivate you guys to go and take your RESTful interfaces and chuck them out the window because it's time. And GraphQL is pretty mature. Facebook did the original work, but now there's hundreds of committers around the world that are doing some really, really awesome work for it. And it's become better typed and more structured as time has gone on. So I'm really excited about it. And like I said, I've bet our application platform in production for it. The second thing we talked about is Scala.js, and you got a little tiny bit of a flavor for it. So, one of the reasons I wanted to give this talk was to talk about how Scala.js is really, really, really ready. And so, if you're a team that is already doing a bunch of Scala, but you have JavaScript that your developers, your front-end guys are using, and you have any trouble at that intersection, definitely give Scala.js a chance, and you can actually just start using it for pieces of your application. You don't have to wholesale adopt it, right? We also use React Native and the Sri project, but we didn't get too deep into it, and that would take a little bit longer than we have time for in this talk. So now we're going to cross our fingers again and try to get to the last piece here, which is, does this work on mobile? Because the entire kind of the purpose of this was to try to make it work on mobile.
Can you get the device ID?
Sorry? Can you get the device ID? I haven't tried. I believe so. I believe React Native itself provides a binding. I don't think we've written a binding for that in the Scala.js layer. Should be easy to add, but I believe it's in the React Native API. Okay, so what happened here is that my window got shrunk when I connected the screen here. So I don't know how to Okay, so something worked, right? Didn't. Okay, so what's the error here? Let's see. No data returned for operation post query. Okay. So we are going to make sure that we're compiling everything. So we are compiling both the web target and the dev target. That's great. We're going to come here and we're going to make sure that React Native is started. And we're going to come here and make sure that we run iOS properly. And let's see. This was working. As you saw, the screen did show the previous values. So we'll see if it works. Okay. And if it does, I'm not quite sure why, because the web app is working, and I tested it right before I connected the screen. Oh, it looks like maybe a network connection.
5% when you tap away.
Yeah, that's what happens when you tap away. Yeah. Okay. So while that's maybe going to load up or not, I have 5 minutes. So if you have any questions or comments, would love to kind of interactively just take care of them. Maybe there's something I can show you in the code or anything like that. Oh my God, it worked! Yes. Okay, so normally what you do now is you would actually get the UI programmer to come in and produfy it, right? And we've got a bunch of examples in this free project that I will put on my screen in a second, where we show you exactly how to do that. We've got tons of examples of everything that you can do and pretty much everything you can do on a native iOS app. Everything from search, from drawing buttons to geolocation, et cetera, et cetera, et cetera. All those things most of those things we've written facades for, and so you can get access to them. Of course, please hire a real UI engineer to do a better job than I'm doing internally here. So while you guys are getting ready for the storm of questions that I'm about to receive, I will go ahead and put up a few links. So this is the organization for Scala, SRI, Sri. Scala.js React interface. And you can see, like, I was coding even last night, and a few hours before that. And so we also have a Gitter channel where you can hop on in and ask questions, or if you want to contribute to this, please, we're looking for contributors and committers. We're very open-minded about giving committer rights to folks who want to contribute and so on. So that's that. The Prisma project itself, again, there is a company behind it, which I really like because I know this is going to be around for a while, but the project itself is open source, totally open source. And they're very responsive. They have a Slack channel. It's constantly busy, and there's some real cool stuff going on there. And then, of course, there is, in this demo, we looked at React Native. And then React Native is something we're trying to hide as much as possible in the Sri project, as much as possible from the JavaScript point of view, and expose kind of nice, structured, type-safe interfaces for it. Well, I shouldn't say we're trying to hide it. We're trying to hide the JavaScript part of it. The React Native interface is actually pretty neat. We're keeping most of it, but it's the JavaScript-ness of it that gets in the way. So we're hiding that as much as possible. I've already told you about the GraphQL story here. GraphQL.org. Take a look at it. It's got really, really nice examples and so on. So those are the technologies that I used for the demo today. Last comments or thoughts? Got a couple minutes.
Does it connect to NoSQL databases?
The question is, does it connect to NoSQL databases? So Prisma right now, which is this the point of Prisma is to just make it really easy to manage the life cycle and evolutions of your schema against a database, right? So that's what it's doing. It's only supporting MySQL and Postgres right now, but they're going to add more. But like, for example, in the production app that I'm working on, for part of my schema, I store that in MySQL, right? Things like user accounts, some results, etc., right? And then I have, if you recall, this layer in the middle, the GraphQL server, where I actually take part of the schema and then send it elsewhere. And there's a bunch of other logic that's not just structured data. It's like unstructured data or a search through something like a key value store, right? That is not going to fit inside even the paradigm of what Prisma is doing. I just carve that out and send it where I need to send it. Like, so for example, file uploads are going to S3, but they're going through GraphQL interface, but the file upload is actually going through S3 and then triggering something else, which is doing analysis, and then putting that back into MySQL, and then subscriptions trigger and the user interface updates, right? So this is very, very nice kind of round trip for that. All right, thank you so much. Appreciate it. I'm here around if you want to talk.